Hello students and welcome to our today's class. Today I would like us to have a look at the quartiles, deciles and percentiles, but to start our discussion we shall first of all look at the quartiles. Maybe we can have a nutshell of what those three terms mean, that is the quartile, the deciles and the percentiles, in as far as the measurement of dispersion is concerned. A quartile is actually a value that divides a distribution into four sets. A value that divides a distribution into four sets is what we normally refer as a quartile. So in this case, you are going to have a distribution, which are actually the values from one end to the other, meaning that we are going to divide them actually into three like that. So we are going to have this part here, we are going to have this part, we are going to have this part, and we also have this part. So the key thing that you need to understand, first of all, we need to find what we normally refer as the median, which is actually the mid-row position. The mid-row position, which is actually the point where the data is going to be divided into two equal sets. We are going to have this set, which we normally call the upper set, and from the median going to the other side, we have the lower set. Then, having divided the data into two, the median of the upper set, which is going to be this value, is going to be what we normally call the upper quartile. This is going to be the upper quartile. And the median of the lower set, which is going to be the value here at the mid-row of the lower set, is normally referred as the lower quartile. So remember, we have the median, which is normally denoted as Q2. Then we have got the upper quartile, which is going to be the mid-row point of the upper set of data, which is normally denoted as Q3. And we have got the lower quartile, which is the median of the lower set, normally denoted as Q1. Maybe we can have an example. Maybe you are given something like this for ungrouped data. You are given values like maybe 7, 6, 4, 2, 8, 9, 10. Maybe we also have 8. These are how many? 6. And maybe you also have 5. And then you are told, can you determine the upper quartile and the lower quartile? What you need to do, the first thing is to arrange them in ascending order or descending order. So we have the smallest is 2, followed by 4, followed by 5, followed by 6. Then we have got 7. Then we have got 8 appearing twice. Then we have got 9. Then we have got 10. These are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. So having arranged them in ascending order, we can be able to locate the mid-row number. The mid-row number, which is actually what? 1, 2, 3, 4. 1, 2, 3, 4. So the mid-row number, which is actually our median, is 7, which is denoted as a Q2. This Q2 is going to divide these sets into two, or these numbers into two. We have got this set, this side, from the median going towards the upper side, which is also known as the upper set of data. And then from the mid-row going downwards, we have got these four values, which is now the lower set. What you need to do for you to get the lower quartile and the upper quartile is to locate the median from 8, 8, 9, 10, which is the median there. So the median is between 8 and 9. So the Q3 would be equal to 8 plus 9 over 2, which is going to be 8.5. This is going to be the Q3. The median is going to be in between these two values. So that is why we get the average of those two values. 8 plus 9 over 2, we get it is 8.5. The lower quartile is going to be the median of 2, 4, 5, and 6, which is actually going to be somewhere in between here. So what we need to do is to get the median of these, which is actually going to be what? Q1 would be equal to 4 plus 5 over 2, which is going to be 4.5. That is actually our Q1. Now, that is how simple you get the quartiles for ungrouped data. For ungrouped data, first of all, arrange them into ascending order or descending order, locate the median, and then you can circle the median if the values are odd numbers, and then locate the median of the upper set and the median of the lower set. The median of the upper set is actually the upper quartile. The median of the lower set is the lower quartile. And sometimes you can be told to calculate what we call interquartile range. You can be told to compute the interquartile range, which is normally given by the upper quartile minus the lower quartile, Q1. So it's going to be 8.5, which is the upper quartile, minus the lower quartile, which is 4.5. You find that the interquartile range is 4. Also, sometimes you can be told to compute the interquartile range, also known as the quartile deviation, also known as the quartile deviation. It is normally calculated by Q3 minus Q1 over 2. So in this case, it could have been Q3 minus Q1, which is 4, and then we divide by 2, which is actually going to be 2. So for the ungrouped data, that is how simple we can be able to compute the upper quartile and the lower quartile. And after having the upper quartile and the lower quartile, you can be able to determine the interquartile range, which is Q3 or upper quartile minus lower quartile, and the semi-interquartile range, which is actually Q3 minus Q1 over 2. Thank you. I want us now to proceed and look a case whereby we have got the grouped data. We can have a grouped data, and then from the grouped data, you are asked, can you get the Q1, which is the lower quartile, and also get the Q3, which is upper quartile. And after getting the Q1 and Q3, you can be asked to get the interquartile range and the semi-interquartile range. So this is the example that is in your notes for this particular lesson. And I want us now to have a solution for that. We get the lower quartile and the upper quartile, and also the ranges, that is the interquartile range and the semi-interquartile range. So here, what you need to do, anytime you are given a question like this, we need to apply the formula that is almost related to the median formula. So we need to first of all have the values for the cumulative frequency, or the CF. So we normally start by 4, then we shall go to 4 plus 8, which is 12. 12 plus 18 is 30. 30 plus 30 is 60. 60 plus 15 is 75. 75 plus 10 is 85. 85 plus 8, we are going to have, it is going to be 93. 93 plus 7 is going to be 100. So the total frequency, our N, is going to be 100 here. Q1 is normally calculated by L plus N over 4 minus C over F, and then we also multiply this part by I. So we normally replace, instead of having N over 2, remember the median is normally N over 2 and the others remain the same. So here we are going to look at it as N over 4, because it is actually the median of the 25%. Remember 25% is the same as a quarter. So we normally get N over 4 here. So the R, it is the lower class limit of the lower quartile class. Q1 is lower quartile. So L, it is the lower class limit of the lower quartile class, and we normally determine it by getting N over 4, or working N over 4, which is the same as 100 over 4, which is 25. Remember, N is 100, so it is N over 4 over 100 over 4, which is 25. So are you able to locate where the 25th profit is going to be? 25th profit is going to be in this that here, because it cannot be in the first 12. The first 12 companies, they had what? They had a profit over this range from 30 to 40, 20 to 30. So what you need to do is to understand that the 25th company is going to be in this 30. Therefore, this class of 40 to 50 is the lower quartile class. 40 to 50 is going to be our lower quartile class, because the 25th company, because here we are talking about a number of companies, the 25th company is going to be in this 30, which belongs to this particular class. Therefore, the Q1 will be equal to L, which is 40, which is the lower limit of this class, plus n over 4, which is actually 25. N over 4 is the same as 100 over 4, which is 25, minus C, which is cumulative frequency above the lower quartile class. Cumulative frequency above the lower quartile is 12 over F is the frequency of this class, which is 18, and then we multiply by the class interval, which is 10. You will realize that if you work the whole of that, you are going to get your Q1 as 47.22. That is going to be your Q1. Then you work out the Q3. Q3 is actually the 75% of the data, which is actually going to be given by R plus 3 over 4 n minus C over F times the class interval I. So what you realize that instead of having here n over 2, we normally have 3 over 4. Remember, I can take you back. Q1, it normally divides the data into a quarter. That's why we have n over 4. Median, which is Q2, it normally divides the data into 2. That is where we normally have n over 2. Q3, it normally divides the data into 3/4. That's why we have 3/4 n. That is why we have it. So it is only this part that will be changing in the formula. Instead of having n over 2, as in the case of the median, we are going to have n over 4 for the lower quartile. For the median, it is always going to be n over 2. For the upper quartile, it is going to be 3/4 n. That's why we have it here. But R, remember, it is the lower class limit of the upper quartile class. So first of all, we need to get the upper quartile class. We need to get the upper quartile class. The upper quartile class, you just do 3 over 4 times n, which is 100. This one you realize is going to be 75. So the 75th company, it is where our upper quartile is going to be. The 75th company is where our upper quartile is going to be. Where is going to be the 75th? The 75th, you normally locate. Remember these values, and this one, you normally locate it in the cumulative frequency. So just go to the cumulative frequency and locate where 75 it will be. So 75, it is actually there. So it is going to be in this particular class of 60 to 70. So the lower limit of 60 to 70, which is actually 60, is going to be our R plus 3 over 4n. 3 over 4n has been calculated as 75 minus cumulative frequency above the 75, which is 60, over the frequency of this class, which is 15, and then you multiply by the class interval, which is 10. If you work out that, you will realize that your Q3 is going to be 70. Your Q3 will be equal to 70, like that. Having obtained that, now you can be able to answer the questions that I said. You can be able to answer the question of determining the interquartile range. Interquartile range is normally given by the Q3 minus Q1. The Q3 we have computed to be 70, and the Q1 we computed to be 47.22. So if you get the difference, you find that the interquartile range will be equal to 22.78. That is it. If you are told to calculate the semi-interquartile range, which is also known as the quartile deviation, will be determined by Q3 minus Q1 over 2, which will be equal to 70 minus 47.22 over 2, which will actually give you 11.39, like that. That is how simple we get it. But the key thing is for you to understand how we compute these values. The key thing is to be able to understand how do we locate the lower quartile class. The lower quartile class is normally located by n over 4. You get the value. This value, you go to the cumulative frequency and locate the value that you have computed there. where the position of that particular value is going to be found. So once you have located where it is going to belong, the class that is going to have that value in the cumulative frequency, it is the class where we are going to have the lower quartile. You take the lower limit, and then that belongs or becomes the L in the formula here. And then C is the cumulative frequency above the cumulative frequency that you have identified, where the lower quartile is going to be. If you identified that is going to be here, the value that is going to be on top of it in the cumulative frequency column, that is your C. And then I is the class interval, F is the individual frequency of that particular class. The same case applies to the upper quartile. Thank you very much. I'm going to come and maybe we discuss on the next, which is actually the decile. Thank you very much.